Good morning, boys and girls. This is Mr. Brooks. Today is day 14 of the NTI work. As you can see here in the game, still got the same little house down below, same animals. Still have the water tower here from the 2-digit edition yesterday when we were counting by ones for the tens. And as you can see, I've also built a castle now up here on this on top of this mountain. So I built a stone castle. Ta-da-da-da. So now you can come up here and be a little bit higher, safer, and just kind of look out and see things a little more clearly. You can hear a kiddo not having a good time right now, but so yeah. So here's here's my new lookout. I don't know. I'll probably just leave stuff down there so I don't have to move it. But got a new castle up here. Let's talk about this castle real quick. This castle is pretty big. It's made of like polished andesite, and so if we were to figure out how many stones of polished andesite this is, there's a lot of math that would need to go into this. For example, we could just solve just this wall right here. To figure out how many stones are on this wall, you could do the length. Great. Hang on. Wait till I'm done with the video, please. Let's use the length and width to find the area of this wall. So the length is, or sorry, the height is 4, or the width is 4, and the length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 4 times 11. Go ahead and try to solve 4 times 11. Alright, so if you count all those punches, it's close to around the answer, and the answer was 44. So if you just look at this wall, it's 44 blocks. Whoa, it's a lot of polished andesite. So you might say, okay, it took 44 blocks to cover that wall. But wait, it didn't. Why not? This is glass. This is a window. So you actually have to take your 44 area, and then you got to take out this area. This is 3 times 2, but probably the easiest way to solve it is just minus 6. So now you got 44, take away 6. Well, if we start at 44 and you count down 6, it's going backwards. 43, 42, 41, 40, 39, 38. So this is actually a 38 block wall. So that's 38. Come over here. This one should also be 44, right? But then we have to take out 1, 2, 3, 4. That's pretty easy, right? Because you have your 44, take away your 1s. So now you have your 40 plus 4 to make the 44. You take away 4, that just leaves us with 40. And then we have a 3 block hole. So now we have 40 minus 3, which is 40 minus 3, 37. So we got 37 plus 38. 37 plus 38. That's going to be 30 plus 30 is 60. 7 plus 8 is 15. So if we do 60 plus 15, 75. So right now we have 75 with these two walls combined. So now we need to do these two side walls. And the good news is they're identical. Okay, they both have the same 4 glass pane windows here. So again, these were 75. So let's check and see what we got here. 1, 2, 3, 4 times 1, 2, 3, 4, 5, 6, 7, 8. 4 times 8 is 32, and 32 minus 4 is 28. So now we have 28 plus 28, or 28 times 2. So you just double it. 28 and 28. That goes to 40 plus 16, 56. So now we have 75 for these two walls, plus 56 for these two walls. That's a lot of numbers. 75 and 56. Ow. So we're going to get some blocks to help us represent this. that's just, I'm already having a hard time keeping up, honestly, with our counts. So 75 and 56. So what we're going to do is we're going to do 1, 2, 3, 4, 5, 6. And 1, well, that'll work. 2, 3, 4, 5. If we count these, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so we did that right. So that's, now we have to do 1, 2, 3, 4, 5, 6, 7. There's 70. And 1, 2, 3, 4, 5. Alright, so 75. There's our 10s, and here's our 1s. 75. That's this one, and then 56 is 50 right here, 6 right here. First, we'll do 6 and 5. 6 plus 5 is 11. Oh no. Oh yes, as you can see, I found more diamond, because now I have a diamond pickaxe. So 75 plus 56. 6 and 5 makes 11. Well, that's a 10 and a 1 left. So we need to bust these up, and we'll move one of these. We'll take 10 of these 1s and make a 10. So now, whoop. Now we have 1 left. If we count these, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, 7 and 5. Yeah, 12, 13. 13 tens! Oh no, 13 tens is not a number. 13 tens gives you a 100 and 3 tens left. So now we need to chop off 10 of these tens. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And we'll put a block over here to represent our hundreds. Woo! Alright, so now, if you look at these, we have 100, 3 tens, and 1 1. So 131. So that's how many, that's the amount of walls inside that castle. 131 blocks. Jeez. So you think, great. So what do we just solve? We solved the area, or the surface area of our walls up here on this castle. And this is really helpful. You know, if you went to Lowe's, for example, and you wanted to buy some paint for your walls, it would tell you how many square feet it would cover. Well, if we pretend each of these is a square foot, it's 131 square feet. So if you wanted to paint these walls, you need enough paint to cover 131 square feet. That's not that big a room, actually. In real life, it wouldn't be. But, you know, 131. Jeez, huge. It's pretty cool. So that's 2-digit addition. So now we'll get down here and we'll do some 3-digit. Alright. Whee! Oh, managed to jump on the cactus and not get hurt, but then we fell afterwards. Got hurt. Darn. Oh no, gotta use a diamond pickaxe. Yep. Alright, so let's see. Griffin, help me out. How many hundreds? 101? Okay. 100, 0 tens, and 1 1. What's our next 100? 41, 42, 45, 42. That's not a number. So 300? Okay, we can work with that. 300. Alright, so first we got 100. Let's do 121. And then the next one we have 300, 70, four. Okay, so we have 121 plus 370. I guess I need to remove this right here so you can really see all the blocks. There's 374. Okay? Really, the main thing, guys, that's really important when you're adding and subtracting, doing all this number work with in the hundreds place in 3 digits, is that you keep it all separate. You really, that's probably the most important thing that students make mistakes on, is they get their digits all mixed up. Okay, so like if you're adding your ones, you can't add ones to tens, and you can't add tens to hundreds. You need to add your ones to ones, your tens to tens, and your hundreds to hundreds. Otherwise, it gets all screwed up. And really, after that, it doesn't matter which direction you go. You could start with your hundreds and say 3 plus 1 is 400. You could start in your tens and say 2 plus 7 is 90. Or, 2 tens is 20. 7 tens is 70. 70 plus 10 is 90. Or you could start over here and you could say 1 plus 4 is 5. And then you just squish it all together. So 495. Okay, that's pretty much the most important thing, again, with a 3-digit addition, is keep your ones, tens, hundreds all separate. If you do that, you'll be golden. Alright, so this week, you all are working on classifying shapes, and you'll be moving on into classifying quadrilaterals. That hurt. So, it's really important when you're classifying those quadrilaterals that you just kind of basically think about what they are, what kind of shapes they are. A quadrilateral always will have 4 sides. So, when you're asked to group them, the easiest way you could always group it is just to say, these have all 4 sides. Yay, I grouped them. But you'll also talk about other traits. You'll talk about, do they have parallel lines? Some of you might be going, what the heck is a parallel line? A parallel means that they run across from each other. So, like, you pretend that parallel lines are like train tracks, right? So these 2 walls are parallel. If I'm walking along this wall going straight, or this wall going straight, they're going to go straight, and they're going to go in the exact same directions. So, like, your train tracks, okay? That's what I like to think about with parallel lines. They're opposite of each other, going the same exact direction. Those are parallel. Then, oops, don't need this one. This right here, this little line, whoop, that 3 line right there on this side, and this one, those are also parallel, because if you were to look at them, they'd be like train tracks. They're heading in the exact same direction, opposite of each other. Okay? This is a rectangle. If we want to classify this shape, we say, what is this shape, Mr. Brooks? This quadrilateral is known as a rectangle, and the reason you know is because it's got 90-degree angles in all the corners. Yes, it does. And it has 2 opposite sides that are the exact same length. So you got it right here, it's 1, 2, 3, and this side is also 1, 2, 3. Those lengths are the same. This one is 1, 2, 3, 4, 5, 6, 7, 8, and that side is also 8. So they have opposite sides the same length, opposite sides that are parallel, and right angle corners. Remember, we said those right angle corners, kind of like those square corners or perfect corners, 90-degree angles. They have lots of names, but they are important to know that those are part of the quadrilateral known as a rectangle. I'm going to leave you with one more quadrilateral today, and this one is a very simple one. I want you to see if you can name it. Anybody know what this quadrilateral is? You should. It is a square. Yes. Now, some of you already know this, but a square is also a rectangle. Say, what? But if you look at it, we said for a rectangle it has to have opposite sides of the same length, and this has 3, and that has 3, and then these 2 sides, that has 3, this has 3. So check, check. Opposite sides are the same length.